All right, so today we are starting chapter 1, and chapter 1 is all about equations. Now, equations are probably my favorite thing about math. I love equations because I love rules. Okay, a teacher loving rules. What's new, right? I love when you have to follow a set rule, and it always works when you do it this way. Okay, and so I've given you guys 4 steps that we can use to solve equations. And all of them use inverse operations. That's your first blank there, inverse operations. My guess, since you guys are the advanced class, is that you guys worked with equations last year, and you probably did more than just 2-step equations. You might have had 3 or 4-step equations. We're going to probably spend our first 2 sections, I should say, our first 2 sections reviewing stuff. There will be some that have fractions and decimals. That'll be good to go over as well. And then it's really our last 2 sections that are going to be relatively new. Okay, so you are going to see equations during this chapter that you have not seen. And then next year you'll see even more equations that you won't have seen either. But you generally follow the same rules when you're working with equations. Yes, Guy?
Why can't I download mine?
Try turning your Wi-Fi off and on. What is there a note that's popping up that says it won't work, or what's?
No, it's just not exporting.
Have you been in Google Classroom today? Is Google Classroom working for you?
Yeah.
Yeah. Okay. I was gonna say try closing out of Google Classroom and Notability and seeing if that helps. Try it again. Let me know if not. Here are the 4 steps to solving equations, and I actually have put these same steps in all of your notes for this chapter. Step number 1, simplify each side if necessary. If there are fractions, we'll clear them. If there's parentheses, we'll get rid of them by distributing. And if there's like terms, we'll combine them. Those are things you won't see in today's homework because today's homework is titled Solving Simple Equations. And so you won't see any of those steps. What you'll see on today's homework is step 2 and 3, where we are separating variables and constant terms by using addition and subtraction. So when you solve an equation, you're used to having one variable term. There might be more than one variable term that you would have to combine potentially, or maybe they're on different sides. We'll talk about that next week. Well, yeah, I guess we will be Friday next week. We will talk about next week what happens when you have variables on each side. We're used to having constants on each side. Okay, the constants are the numbers that don't have an x or y or whatever your variable is. Those are just regular integers. Okay, or they could be fractions or decimals. They're usually integers. So we want to separate them. We want to get all the variable terms on one side. We want to get all the constant terms on the other side. And once we do that, our final step, if needed, sometimes it's not needed, but our final step is to multiply and divide to get x or our variable by itself. The 4th check is the fourth step is a very underrated step, which is checking your answer. The nice thing about equations is that you can plug your value of x back into the original equation to see if both sides equal out. Now, it's underrated because everyone's like, well, I'll just use my check answer button, and I get that. You don't have a check answer button on your quizzes, on your tests. So this is where the step is really nice. Okay, you can be certain of what your score is on the test because you've checked your answers and you know their work, versus saying, handing it in and saying, I hope I did well on that. Okay, that won't be something you have to worry about. You can use your iPad. So let's look at the first one here. It says solve each equation. X minus 7 equals -6. There is one variable term in this equation. What is that variable term? Lizzie. It's x. Yep. And there's nothing in front of the x, so we can just assume it's a 1x. Okay. There are 2 constant terms. Jimmy, what are the 2 constant terms? That's right, -7 and -6. And if you didn't see that as a -7, you need to start thinking of it as a -7. In this chapter, when we're solving equations, we look at those subtraction and addition signs and we think of them as positive and negative symbols. So when I ask you about that term right there, that's a -7. Okay. And what's the opposite of a -7? Sky? +7. That's exactly what we're going to do to try to get that variable term by itself. To get x by itself, we're going to put a +7 on both sides. That will allow it to cancel out with the -7. And then on the right side of the equation, when you have -6 and +7, that gives you what? Garrett? +1. Okay. We have gotten our variable term isolated. We moved well, I guess we could say we moved it. We actually canceled out the constant term on this side by moving it over to the other side as a +7, and that gave us a +1. And we can check our answer to make sure it's right. 1 - 7 or 1 + -7 does give you +6. So it's correct. Example B. Y + 3.4 = 0.5. Maddox, what do I need to do to both sides to get y by itself?
Subtract 3.15.
Perfect.
Subtract 3.4.
That's because a -3.4, I know he said subtract, which is correct. Okay, a -3.4 cancels out with a +3.4. So that's going to go away. You'll get y equals, and then I can use my calculator. So I can do 0.5 - 3.4. If you didn't have a calculator, you know it's going to be negative because you have a larger negative number than the positive number, and you'd have to do this. Well, we have a calculator. Or you could use your brain power. Either way, what should you be getting? Lizzie? -2.9 is correct. I guess my door's not shut. That's just really loud. Yeah, it's loud. Christian. Your calculator's not turning on. Do you want to try borrowing one of mine? And I'm not sure. I can look at it later to see if it's still working. Sky, did you get into okay. Example C. Now this one looks interesting. You don't see too many equations that have pi symbols in them. Well, coming from our last chapter, we know it's possible to write an answer in terms of pi. Both these constant terms are written in terms of pi. What we can't see this equation as is having two different variable terms. Pi is not a variable, pi is a number. So these two terms right here are both constant terms. There isn't a variable there. Pi being a number, 2pi is still a number. Okay, we would call it 6.28, right? Or 3pi. Okay, 3pi would be what, 9.454, 53? What is 3.14? 9.52, 3.14 times 3. 9.42. Okay. Either way, we still want to get h by itself by removing this constant term from that variable term side. So Connor Kendall, what's the opposite of a positive 2pi? And when you combine a positive with a negative, you're going to subtract. We're going to have war here. Connor, what's 3pi minus 2pi? Pi. Yep, 1 pi or just pi would be fine. Yep, h equals pi. Next one, -3 equals k plus 3. Emerson, what do I need to do to the variables side to get k by itself? Add 3 to the variable side. Wouldn't that make that k plus 6? Well, that doesn't make it go away. So you add what? Subtract 3, okay. That'll make the positive 3 go away. Now we just have k. So the variable's been separated. And then on the left side, Emerson, -3 and -3 makes, that's right, -6. Yep, same signs, keep the sign and add, -6. Again, these are pretty much just one-step equations that you guys are solving here. I don't need you to write k on the left side. If it's on the right side and you want to leave it there, that's fine. This -6 equals k or k equals -6. It's the same thing to me. So don't feel like you have to flip it around. In fact, I see people flip it around all the time and it's fine this chapter, but when we get into our next one, which is over inequalities, you can't flip it around without flipping the inequality symbol around. So people get confused why they're getting them wrong. It's because they didn't flip the symbol around. So that's just to leave it on that side. Let's just leave it on the right side. Example E, D minus 1/4 equals -5/8. Xander, tell me what I need to do to get D by itself.
Add 1/4.
Okay. Now, 1/4 is the same as adding how many eighths, Xander? 2 eighths. And what's -5/8 plus 2 eighths?
-3/8.
That's right. And we can write that negative up here with the 3, off to the side, down here, as long as it's there, there's only one of them. Example F. 5.6 plus Z equals -8. Oliver, tell me what I need to do to get Z by itself.
5.6 from -8.
Okay. And again, I can use my calculators for this. Or let's see if you remember how to do this. When I'm adding or subtracting, do I have to line the decimal points up? Yes, I have to, right? Multiplying, I don't, but adding and subtracting, I do. So now they're lined up. Now, my integer rules state that when I am adding, well, I know I'm subtracting, but think of it in terms of adding. The reason I like writing it like this is even though he said subtract 5.6, it's the same as adding a negative. So if I think about it like that, I've got same signs. And when I'm adding two numbers that have same signs, they join forces. What does join forces mean? What am I actually going to do here? Carson? Okay, so would you add the 8 and the 5 and the 0 and the 6, or would you subtract them?
You would add the 8 and 5 plus 6, and then you would make that negative. So
Go ahead.
13.6.
That's right.
I was counting because I don't really put 5 in.
Yep, that's right. So even though we said subtract 5.6, we know if it's already negative, it's going to get more negative. So our integer rules take over and they say, well, if you have two with numbers with the same signs, they join forces, they stay negative, and together make -13.6. Again, your calculator is a great resource as well. But I don't want us to forget our decimal and fraction rules just because we're using calculators now. Example G. 3/4 n equals -2. 3/4 n equals -2. Owen, what's the 3/4 doing to that n? Multiplying, and so using inverse operations, the opposite of multiplying is dividing. Okay, so I'm going to divide this side by 3/4. Dividing by 3/4, Owen, is the same as multiplying by what? Well, you could do that. We'll get to that in a second. Let's stick with fractions for right now. Dividing by 3/4 is the same as multiplying by what? 4/3. Yeah, kind of the opposite of what we did last chapter with those spheres. And we're supposed to be multiplying by 4/3, so we divided by 3/4. Kind of opposite here. So I'm going to make this 2/1. And then do I have anything that cancels? No. Okay, so I did multiply, then I'm going to get 8/3, it looks like, negative, because that was actually a -2/1. Don't forget about that. So -8/3. I'm okay if you want to read that as an improper fraction. If you were to write it as a mixed number, as some of you might do, what would you say this is as a mixed number? Alex? -2 2/3. Okay. Now I say that because going back to what Owen was just saying, he was saying maybe we should use decimals, right? Well, you could call 3/4 0.75, which means you'd be doing -2 divided by 0.75. But I get a repeating decimal in my calculator. Well, remember we talked about repeating decimals. Especially if it's a 3 or a 6, this one's a 6 that repeats. We know that 0.6 repeating is 2/3. So that's why I was wanting to keep this one as using fraction rules, Owen. But as long as you know that 0.6 repeating is 2/3, that's fine. And the reason I'm saying that is because Big Ideas isn't going to let you type in 0.6 repeating. There's no way to type a repeating decimal in. They're going to want you to write it as 2/3. Or 8 or 2, -2 2/3, or it'll even accept -8/3. They'll be okay with that too. Okay, next one, example H. Pi x equals 3 pi. Where's the variable term, Deegan? It's on the left side or the right side? Yeah, it's right here's the x. Yeah, kind of confusing because the pi symbols again. What's the pi doing to the x?
Multiply,
So what are we going to do?
divide.
Divide. So I'm going to divide by pi, divide by pi. What happens when I divide 3 pi by 1 pi?
Just
Why is it just 3?
because both pies cancel out.
That's right. The pi's will cancel out. And you're left with x equals 3. That's right. So I don't know if you noticed, but we kind of went in, we were doing addition and subtraction equations, then we kind of got into the multiplying and dividing equations. That's what we've been doing here recently. This one looks like a fraction, and it is a fraction, but you could read this one as m divided by 4. You don't have to read it as m fourths, okay? Lucy, what's the opposite of dividing m by 4?
Multiply.
Yep, so all we have to do to invert that is to multiply both sides by 4. And Lucy, what's -7 times 4? That's right, -28. All right, example J, just kind of throwing all kind of examples out here, some that are easy and some that are decimals and some that are fractions. 0.09W equals 1.8. Martin, what do I need to do to both sides to get W by itself?
Divide by 0.0.
Perfect. I would use my calculator for that. Martin, what do you get for 1.8 divided by 0.09? What'd you say? 20, okay, 20. W equals 20. Now, remember, dividing by decimals is something we talked about earlier in the year when we were doing that preliminary unit. 1.8 divided by 0.09. Just to remind you how to divide by decimals, the outside number cannot be a decimal. So what I would do is I would take the decimal point on the outside, I would slide it over twice, slide this one over the same number of times. And so the reason we're getting 20 is because 9, not 0.09, but 9 goes into 180 20 times. Okay, so you would still get your answer of 20. Okay. All right, next one. -z divided by 3.6 equals -0.18. Now the negative is floating there in the middle, but I can't just get rid of the 3.6 and leave it as -z. I need z to be by itself. So what I would do is I would take the negative, and when I write this down on my paper, which I'm going to want you guys to do on your work papers, go ahead and write the original equation and then what your work is. So you notice I'm writing my work. Most of these have just been one step. That step may be dividing by pi. That step may be dividing by 3/4 or timesing by 4/3, however you want to write it. That step may be as easy as multiplying by 4, like we did on this one, but go ahead and write down the original equation on your work paper. Show what you're doing to both sides, and you can write your answer. If you've already started your work paper and you didn't do that, it won't be too difficult for you to go back and next to your answer, write down what the equation was and what you did to solve it. Okay, but back to this one, when I'm writing this one down, I'm just going to go ahead and write the negative down here with the 3.6 because I want to get rid of that whole thing as a package deal. So what is the opposite of dividing z by -3.6?
Multiply.
Multiplying it by -3.6. Jacoby, what do you get when you multiply a negative with another negative? Okay, so don't even worry about typing the negative into your calculator. Jacoby, what's 0.18 times 3.6? 0.648. I guess that's right, isn't it? Okay, let's look at another one here. Example L. It just says it's just a triangle. It says 47 degrees for one of the angles, 22 degrees for another angle, and then x degrees for the last angle. And assuming we're still solving for x here, right? It said solve each equation. This one's not really an equation, but we could make an equation. If I made an equation for this shape, what would it say? Pardon?
It'd be 47 plus 22 plus x equals 90.
Not 90. How many degrees are in a triangle? not 90,
180.
180, that's right. So 47 plus 22 plus X. So adding all three angles in a triangle together will give you 180 degrees. You guys learned that last year. We'll talk about it later as well. When we do more with triangles. We do quite a bit with triangles this year. So in this particular one, I'm going to revert back to a step that I have not used today, all the way at the top of our notes. This step is called combining like terms. It's under the simplifying each side step. So one of the ways that I can simplify that side is by combining the like terms. And like terms have the same variable, or like terms can be terms that have no variable at all, which are the constant terms. Constant terms are like terms. So Jacoby, what will I get when I add this constant term with this constant term? 69 degrees plus X equals 180 degrees. Okay, so I've simplified. Now I can get rid of that 69 degrees by, what do you think? Adding or subtracting? What do you think, Dawson? Sorry, blank. Subtracting, that's right. So Dawson, tell me what 180 minus 69 is. 111. Perfect. I wouldn't require you to put a degree symbol there. The wording is kind of, now there is no wording on this one. If they say find the value of X, I'm okay with just putting 111 degrees. If they ask you to find the measure of X, that's when they're looking for degrees. Okay, so it kind of depends on the wording, and we'll focus more on that. We got a chapter that's not exclusively triangles, so we'll focus that more on later. So X is 111. We can just call it that one. Okay. And then our last question today in our notes, and you guys will get some homework time, obviously, says the melting point of a solid is the temperature at which the solid becomes a liquid. Okay, so for example, ice turning into water. The melting point of bromine is 1/30 the melting point of nitrogen. Write and solve an equation to find the melting point of nitrogen. Now, one of the things that you may, I don't think you have to do this anymore on the iLearn test, but back when the I-STEP test was still around, they would give you a point on the I-STEP test just for telling what variable you were using and why you were using it, like what did it stand for. So they'd say like let whatever letter you're using represent, and then you had to explain what it was being used for. I think that's a good habit, and I'm not going to make you do that every story problem, but I think occasionally it's good just for us to take a step back and think, what are we actually trying to solve here? Read that last sentence again. Write and solve an equation to find the melting point of nitrogen. What variable do you guys want to use for the melting point of nitrogen? Lizzie? M for melting point. Okay, so let M represent the melting point. But specifically, because we have two different chemicals here, or two different, I don't know if they're compounds or they're on the element chart here, but the melting point of bromine. Oh, sorry, nitrogen. I just said the wrong one, not bromine. Okay. We actually know what the melting point of bromine is. If you look closely enough, you might find it. What is the melting point of bromine? Go ahead, Owen. Yeah, -7 degrees. Okay. I know that the melting point of bromine is 1/30 the melting point of nitrogen. That was given to me in the problem here. So my equation will look like this. I'm literally going to take this sentence here, and I'm going to reword that sentence as an equation, plugging in the variable I'm using, plugging in the numbers they give me. Sorry, this is distracting me. Students throwing footballs through the window. So let's start with the melting point of bromine. Owen just said that's -7. So in that sentence where it says the melting point of bromine, I'm going to replace that with -7. And then we see this word is. What mathematical symbol can I always replace the word is with? Jimmy? Equals. That's right. You can always replace is with equals. X is 7. Well, okay, X equals 7, right? That kind of makes sense. And then it says 1/30 the melting point of nitrogen. If I want to find what 1/30 of that melting point is, I'm going to multiply by 130 or 1/30. Sorry, not 1/30, it's a different number. So I'm going to multiply the melting point of nitrogen by 1/30. I don't know what the melting point of nitrogen is, but Lizzie said, let's use the letter M to represent it. Okay, so 1/30 M. So there's our equation. The 1/30 is being multiplied. So what's the opposite of multiplying by 1/30? You could say two things. Give me one of them, Carson. Dividing by 1/30. Yep. Or you could say, Seth, multiplying by 30. Yep. So we know that dividing by a fraction is the same as multiplying by its reciprocal. And Seth, what's the reciprocal of 1/30? 30/1, which is 30. Yep. So, and by the way, another way that I could have written this equation, and I would have been fine with if someone did this, you could write it as -7 equals M/30. Looks a lot like the one Lucy did earlier where we saw we just had to times by 4. That's kind of what's going on here. We just really have to times both sides by 30. That's because taking 1/30 of a number is the same as dividing it by 30 in the same way that taking half of a number is the same as dividing by 2. We did that a lot when we were finding the area of a triangle. Sometimes we'd say half, sometimes we'd say divide by 2. This time we're going to say 1/30 or divide by 30. And the opposite of dividing by 30 is multiplying by 30. And I need to go ahead and answer this. So -7 times 30. What is that going to give me? Go ahead, Xander.
-210.
And it's a story problem, so I want to label it. What would I label this as? Where are we measuring the melting point? Degrees, more specifically degrees Celsius. Yeah, and I know it's degrees Celsius because they gave me the temperature of bromine melting point in degrees Celsius as well. So every story problem has to have a label, and ours does now. Lizzie? It would be annoying. Yeah, you're gonna have to do that later. Not today, though. We'll save that for a different section. Yeah, Sky? Oh, inverse operations. Yep. Any other questions? About 10 minutes left. You guys can open up your 1.1 homework if you haven't already and get started. Maddox? A work page? Yes, I just described what to write on the work page a few moments ago. Did I not? Did I dream that? Yeah, I did. Okay. Yeah. I know the chapter, I told you the chapter 1 opener didn't need a work paper, but this one does. Yes. So you need me to unsubmit it? Sure. Jace? Sure. Anybody else? All right, I'll go ahead and turn this recording off.